In today's math lesson, we're going to solve compound inequalities. When working through these compound inequalities, you're solving just two inequalities using the regular rules of solving. So the original setup or display of the problem looks a little different, but the rules that you use are still exactly the same. Example 1, solve for p, where p plus 15 is greater than 17, or p plus 17 is less than or equal to 3. In working through these types of inequalities, it's important to realize that you're solving two separate inequalities. So if it helps you to just cover one of them up so that you can then solve for the one that's visible and then cover the original one, the first one up, and solve for the second one, then that's fine. Or use two different colors. Something simple just to help your brain realize that we're solving for p over here, and then we're going to do it all over again over there. So let's start with p plus 15 is greater than 17. We always start by drawing the river just to help your brain recognize the left side from the right side. And then with p plus 15 equal to 17, we can just subtract 15 from both sides of the river like normal. And we see that our 15s cancel out by design. And as a result, p is greater than 2. Okay, great. So on our second inequality, we have p plus 17 is less than or equal to 3. Again, starting off by drawing our river. And now we can solve for p by subtracting the 17 on both sides of the river so that the 17s on the left cancel out by design. And thus p is less than or equal to 3 minus 17, which is negative 14. You'll notice that our original problem has the word or in between the two inequalities. So yes, that means that your final answer should also have the word or in between your two inequalities. So as a result, our final answer is p is greater than 2 or p is less than or equal to negative 14. And there you go. Example 2. Solve for d, where negative 5 is less than or equal to d plus 13, which is also less than or equal to 13. This compound inequality is written out as one statement, and we need to solve for d. So it looks kind of weird as we get the process started in solving, but it's not too bad. So you have what would in equations be two equal signs, but with inequalities you have two less than or equal signs. And we're going to draw rivers through both of them, essentially creating an island in the middle with shores on either side. So we need to get d alone. And to get d alone, you would need to get rid of the 13 that is right beside it. And you would do that by subtracting off the 13. And we've said from the beginning of solving for an unknown that whatever you do on one side, you have to do to the other. Well, whatever you did in the middle on the island, in the middle between your two rivers, you have to do on both shores, on the bank of the East and the West Nile River. Okay, I don't know. I was going somewhere with that. So the 13s in the middle cancel out by design. Negative 5 minus 13 is negative 18, which is less than or equal to d, which is less than or equal to 13 minus 13, which is 0. So we subtracted 13 that was in the center with our variable on both the left and the right sides of our inequality to get our final answer in one clean statement. And there you go. Example 3. Solve for m, where m minus 11 is less than negative 17, or m minus 12 is greater than or equal to 4. This compound inequality is an or statement, so I have two completely separate inequalities. So let's begin the process of solving the one that's on the left. Here, this m is minus 11 less than negative 7. So let's get rid of the 11. And we do that using our normal rules of doing the opposite. It was subtracting, so now it is adding. Thus, my 11s cancel out by design, and m is less than negative 7 plus 11, 4. All right, that wasn't too bad. Now let's work through our second inequality, where m minus 12 is greater than or equal to 4. All right, so we need to get rid of the negative 12. And we do that using its opposite, which is adding. And what you do on one side, of course you do to the other. And we did that so that our 12s would cancel out by design and intention. As a result, m is now greater than or equal to 4 plus 12, which is 16. And just like our original inequalities had an or between them, our final answer will also have the word or between them. Thus, m is less than 4, or m is greater than or equal to 16. And there you go. Example 4. Solve for c, where 16 is greater than or equal to c plus 1, which is greater than negative 1. In this example, we have a compound inequality that's written out as one statement. And just to make it clear, whenever you have a compound inequality in one statement, your variable will always be in the center portion of that inequality. All right, let's begin the process of solving for c. So we have our two rivers and our c, our variable is there in the center on the island. And we need to get the c all alone, so we're going to do that by subtracting off the 1 that's there with it. And what you do on one side of the river or in the island, on the island between your rivers, you have to do both on the east bank of the river and the west bank of the river. So all of your center ones cancel out. 16 minus 1 is 15, which is greater than or equal to c, which is greater than negative 1 minus 1 more, which is negative 2. And there is our compound inequality, nice and clean and tidied up. So there you go. On our fifth and final example, we're going to solve for s, where negative 11 is less than 2s plus 9, which is less than or equal to 3. Since our compound inequality is written in one statement with our unknown variable in the center, then we have to draw two rivers with an island in the center so that we can go ahead and solve for s, our unknown. So we know that when you are going through the process of solving for a variable, you have to get rid of the adding or subtracting term first. Let's get rid of 9 by subtracting it off the center, but also subtracting it off of the east bank and the west bank of our rivers, so that the 9 in the centers cancel out by design, and that gives us negative 11 minus 9, well, that's negative 20, less than 2s, which is less than or equal to 3 minus 9, which creates negative 6. All right, so now I've cleaned up my center by getting rid of the 9s, but I have to take it one step further. Let's divide off the 2 from our island, and where we divide on the island, we also have to divide on both sides of our river, the east and west bank. The 2's in the center cancel out, leaving us with negative 20 divided by 2 is negative 10. which is less than s, which is less than or equal to negative 6 divided by 2, which is negative 3. And there you go. Nice and solved for s.